Okay, I hope you're ready for the final lesson of this chapter. Today we'll be talking about mean, median, and mode, and also range. Okay, mean, median, and mode are all called measures of central tendency because they tell you the center or what the data tends to center around. I'm not going to spend a lot of time on these definitions because you have heard them before. Okay, another word for mean is the average. And to get the mean, you take the sum of the data terms divided by the total number of data terms. In other words, you add all the numbers up and then you divide it by how many there are. The median, it's the middle value of a data set when the numbers are in order. So that means you have to put them in order from least to greatest, greatest to least. And then you have to take whatever number is in the middle. If there are two numbers in the middle, the median is the mean or the average of the two. Okay, so if you have two numbers like 10 and 11 that are both in the middle, you take 10.5 would be the median. I like to remember median by thinking I'm driving on a highway and the median is in the middle. And the last of these terms is mode. The mode is the data item that occurs the most often, and it is possible to have more than one mode. Okay, but mode, most, that goes together. An outlier is a data value that's much higher or lower than the other data values in a set. So for instance, if we think of something like the house prices in State College or something, and you notice that you're in a neighborhood and one house is 250,000, the next is 300,000, 320,000, 325,000. And then let's say someone comes in and buys a vacation home in State College because they love the football team, and this someone happens to be a celebrity. We'll say, Justin Bieber moves in, and he is rich and he buys a $2 million house. Okay. That would be an outlier. And what's important to know about the outlier, because it's not near the other data points, if you look at an outlier, you're going to notice, well, if we had this original data set, you could see like the median would be like halfway in between 300 and 320, which would be 310,000. And now that we have this outlier in here, now there's 5 terms, so the new middle is 320,000. So you're going to notice the median did not change a lot by the outlier. But if you look at the mean then and kind of compare what's happening there, you're going to see that the old mean, if I add up all these numbers, 250,000, 300, 320, 325, and divide by 4 how many there were, the old mean, put that in purple, the original mean was $298,750. And now if I put in this new mean, so I add them all, including the 2 million, and divide by 5, the new number of numbers, the new mean is 639,000. So this time it changed a lot. So it's important to know that a mean really affects an outlier really impacts a mean. It doesn't usually change a median much. Okay, we're going to look at this data set, and your job is to find the mean, median, and mode of the data below. And then I want you to tell me which measure of central tendency best describes the data. And remember that a measure of central tendency is something that tells you about the center of data, so it's either mean, median, or mode in the cases that we know. I would say pause this and try to work it out. Okay, and then you come back and check your work. So if I'm going to go ahead and find the mean, I'm going to add up everything that there's here, and I'm probably going to use a calculator. So these might be numbers that are easy enough to do in my head. So I'm summing them all, and I'm getting a sum of 77 when I add them. If I do a quick count, I notice that there are 7 terms. So to find the mean, I will do 77 divided by 7, and I get a mean of 11. Okay. If I'm looking to find the median, the first thing I want to do is put them in order least to greatest. So it looks like 2 is the smallest, And it might be smart to cross off as you go. Then next comes a 10 and another 10. There's a 12, a 13, a 14, and a 16. Okay, so when we're trying to find the median, I'm trying to figure out what number is in the middle here. When you have small data sets, it might be kind of easy to see. It might be helpful to know this. If you have an odd number of data points, there will always be a number in the middle, like one number in the middle. If there's an even number of data points, there's going to be two numbers in the middle, and you're going to have to take an average. So we can see here, like there are three numbers over here and three numbers over here. So there's just one number in the middle, a 12. That means 12 is my median. If I hadn't had the 16 or something, then 10 and 12 would have both been in the middle, and I'd have to take the average of those. Okay, and then the last one, we'll look at the mode. The mode is the number that occurs the most often. So in this case, you're going to see there's one of everything except there's two 10s, so 10 occurs the most often. It's the mode. Okay, this tends to be a tough problem for people. So it says, suppose your grades on 3 science exams are 82, 94, and 89. What grade do you need to get on your next exam to have an average of 90? Okay, so what I know here is I am having an 82, a 94, an 89, and some unknown grade here. And I want an average of 90. Okay. You've got a calculator, so you could guess and check this problem all you want until the cows come home. It might take you a little bit of effort to do, so I want to teach you a couple cool strategies that might help you for this kind of problem. So what I know is to get an average of 90, and I'm going to have 4 data points. So usually what I want is some number, I don't know what that is going to be yet, and when I divide it by 4, I want to get an answer of 90. Okay, I want you to think like if I'm taking a number and I'm dividing it by 4 to get an answer of 90, you might want to kind of work backwards and use inverse operations to figure out what that value is. So a good way to do that is say 90 times 4 gives me 360. Therefore, 360 divided by 4 must be 90. So in this case, I want my 4 numbers, my 4 test scores, I want them to add up to 360. Because when I divide 360 by 4, I'm going to get an answer of 90. So I'm going to see what 82, 94, and 89 add up to already. And 82 plus 94 plus 89 equals 265. So I want to say 265 plus what? I'll call that x. Is going to equal 360. So there I can just do 360 minus 265. And it looks like my answer is going to be that I need a 95 on this next test to bring up my average to 90. And if you don't believe me, you can double check that. You can do 82 plus 94 plus 89 plus 95. Lo and behold, that adds up to 360. And when you divide that by 4, how many test terms you have, you're going to get 90, exactly the average you needed. I've got another cool super secret shortcut to do that if I have time at the end. Or you might want to ask me in class if I don't say it here. Okay, the range is the difference between the greatest and least values. So difference, remember that means to subtract. So you're just going to tell me the difference between the greatest and least. Okay. In this example, you're going to find 2 things. You're going to find the range and the mean of each set of data. So remember, mean is average. And then I want you to use the range to compare the spread of the 2 data sets. Okay. So go ahead and find the mean. Remember, you're going to add up the numbers and divide by how many there are. The first one, they add up to 200. So the sum is 200. There are 5 numbers. So if I do 200 divided by 5, I get a mean of 40. Okay. The second one, if I'm adding to 56 and 35, 27, 47, and 35, they also add up to 200. And there's another 5 numbers, so the mean is also 40. Okay, so both of these have a mean of 40, but what's going to be different is probably the range. So I'm going to look at the first one and I'm going to say, what's the smallest number? 34. And what's the largest number? 47. So I can do 47 minus 34 and I get a range of 13. So 13 is my range for set 1. That doesn't look like much of a 4, but set 2, it looks like my smallest number here is 27 and my biggest number is 56. So here I'm going to do 56 minus 27, and it looks like I have a 29 for my range. So what you could say about the ranges here is the second set has a large range. It's widely spread. And the first one is more narrow. It's more close together. Okay, stem and leaf plots. You guys have done some stem and leaf plots in the past. So when you're drawing a stem and leaf plot, you usually have like a bar here, and often your stem represents tens. It could represent something else. That's where you're going to make a key. But in this case, since these are all 2-digit numbers, it's probably going to be smart for me to have my tens here and my ones here. You're going to need to go from your lowest to your highest. And it looks like I've got the 44. Right now I don't see anything lower, and I see a 66. We'll see if I see anything higher later. But it looks like for my tens I only need a 4, a 5, and a 6. I tend to just start writing in order, like starting at the 56 and go. So if I want to write a 56, like I know the tens is a 5 and I put a 6 in the ones column. And I'm going to write my 44, so I have a 4 and I'm putting a 4 in the ones column. 63, I'll put a 3 here with the 6. 58, I just throw an 8 next to that. 51 here, 59, 47, 51, 67, 50, 65, 49, 66, 63. Okay, and that's like a good start, but they're not in order. And we always like our stem and leaf plots to be in order. So if I'm going to finalize this, the 4s look good, 4, 7, 9, that's least to greatest. The 5s, it looks like I need to start with a 0. A couple of 1s, 6, 8, 9. And then the 6, 3, 3, 5, 6, 7. And this is a good stem and leaf plot now. And a good key might just be to say like 6, 3 means 63. Because, I mean, sometimes you could have it mean 6.3 or something else like that. Okay, here is a stem and leaf plot for a double stem and leaf plot. So we're comparing mileage of cars for 60 new cars, what mileage they get in the city and on the highway. So like this might be different. The highway looks normal because it's the normal way you look at it. So like this number here means 24. City might confuse you a little bit because it looks kind of backwards. But like this number here, the stem is still in the middle, so that number means 38. Okay. Okay, if I'm trying to find the median, I know that there are these different cars, okay, and I'm trying to find the median for the city and the median for the highway. So I'm going to try to count how many there are. In the highway, if I look here, it's 1, 2, 3, 4, 5, 6, 7, 8. So I know that's an even number, so 8. It's going to be halfway between the 4th and the 5th number. So if I'm looking here, 1, 2, 3, 4, 5. So here's 4th is the 0, and 5th is a 5. So it should be between 30 and 32. It looks like my median for highway is 31. If I'm trying to find my median for city, it's gonna 1, 2, 3, 4, 5, 6, 7, 8 cars again. So I'm going to go halfway between the 4th and the 5th. So I'm going to go 1, 2, 3, 4. Here's the 4th. Here's the 5th. It looks like halfway between 21 and 24. It looks like 22.5 is my median here. Median for city. So you can see that cars in general tend to get better gas mileage in the on a highway because they aren't having to stop. Okay, last closure. When should the median be used and when should you use the median? I showed you the answer, so just want you to remember that If there's an outlier, use the median. If there's not, use the mean. Okay, good luck.